Jesus Christ, it's fucking cold. What up? Welcome. This is a bit different. I will be using this, and it will be going somewhere around here. Oh, I might adjust this. Like that or something. A bit more extension and... What the hell? I have not prepared for any of this. Hey Death, how's it going? Oh. This is shockingly bad. Why is that so? Alright. Really, you want to make that. Point it down there. There. Now, if I use this camera... Oh god. Well, we will be focusing on this, so maybe a bit lower? Okay. That's terrible. What if I do move it this way? Then I might be able to sort of angle it right. Eh. That'll have to do. Is it in focus? I can't really tell. Yeah, I'm good. I'm good. Just decided I wanted to start on my project now that I've got everything. So, for those who don't know what we're building this. Oh. It's on Discord, but, that's what we're building. Now, we're only building the clock module for this, because after that, we will transition onto this. Oh, it's upside down. That. And then after that, this is the pièce de la résistance. We'll be going to this. This box is actually quite heavy compared to the rest. The world's worst video card. Which you will see here, this monitor here, is what I'll be connecting it to because it supports VGA. I don't have anything else that supports VGA. That does mean it's going to be a bit difficult. I may have to move the monitor that way. Otherwise, yeah. So right now we have all the stuff out here for the little clock module. Now, I don't technically have to make the clock module. I don't technically have to make the clock module, but I want to because then otherwise I'll be stuck with 1 megahertz, and debugging 1 megahertz is actually going to be kind of difficult, considering literally everything on this thing is written in like assembly language. Now there is prep I'll have to do before I start that other one, but this one requires no prep. Is it really the worst if it's that small? No. Alright, so what you don't know is the world's worst video card. It supports 100 by 75 pixels, 64 colors, and 1 frame a second. Hopefully I'll be able to improve that last part with some possibly clever trickery and maybe buying a few more bits and pieces off of the internet. Yeah. We'll see. We just gotta build it first. That's like way down the track. That's experimenting with stuff for myself. Okay. Another thing you'll see me have is these needle nose pliers are tiny. These wire strippers, because you know, and side cutters. Whether I actually end up needing those, I don't know. Anyway, let's go to where should I put this? That side? Well, that side. You know what? I always like top left. It's like my favorite spot. It's like standard for me. Some older techs might have similar specs, except for the 1 frame a second. I don't know too many things except maybe a calculator that has 1 frame a second. Or like, I know what has 1 frame a second. An electronic ink screen, but that's usually got higher resolution anyway. So, yeah, we won't be doing this one first. This is the 6502 based computer kit I have. This is the YouTube tutorial for it. We're doing this first. The 8-bit computer clock stuff. Starting with the A-stable timer. I believe is this chip. Well, one of these chips. One of the little ones, because they're all the same on the right. I also have with me a torch, so I can actually read the lettering on the chips. And it does strobe. Oh, no, this isn't that. So the 6502 computer is historic. Believe it or not, the 6502 is like the granddaddy to all modern desktop PCs you see today. This big boy here has its roots in a chip that I have in there. I mean, granted, it's a modern version of a chip, but still, you know, whatever. Otherwise, this is what we'll be starting now. I'm going to stop the BGM. I do have some other lo-fi if I get bored of that. I've just literally pulled up a lo-fi live stream that claims it's no copyright. I may use that. Thanks, who was it? Lo-fi Geek. But yeah, so we're going to start with this. You're going to hear a lot of this guy.
Something that's relatively flexible. We can adjust the speed. You know, we don't want it to run too fast. We want to be able to see what's going on. And so,
all right. And yes, I will be referring to a lot of these. Stop doing that. It's stuck.
It's relatively flexible. We can adjust the speed.
You know what? Let's just use
there are a lot of ways to build a clock circuit for a
done.
computer. But, you know, we want something that's
so this is where we start.
We can adjust the speed.
Okay.
We don't want it to run
so
too
I'm
fast.
going to use that image as a reference because I can sort of see everything here. So I'm going to guess that that's exactly, that what I'm seeing up there is exactly what I need. Okay. And with that being said, oh, I think this lo-fi is running. Okay, that's fine. We'll leave it like that. All right. Cool. So if I go back to this camera, I don't think I'll be able to do what he does. Hold on, will I? Is that focusing? Not really. Oh, there we go. Now it focused. Okay, that works brilliantly. Except this is the wrong way around. There, now we get the A, B, C, D, E. Oh man, he has blue lines instead of black lines for the negative. No. So, let's see. The first thing I will need, from what I can see, is these chips. Specifically the little ones. There are 3 of them, because inefficiency is key in these projects. There's the little chip. It's so small! How many freaking things are down? Alright, so see this 5 line? See, I'm gonna try and put it exactly the same spot you can see. There? Am I looking right? Yes I am. So let's just... And the notch appears to be facing down? I think. I don't know. I think I need to change it, check the resolution on, yeah. Go higher resolution, please.
See what's going on. And so I'm going to use the 555 timer. This is a classic.
Okay. So the first pin should be top left. There's a little notch in top left. This 5.5 timer doesn't have a little notch in the top left, but it does have one on top. A little... what is that? Is that dirt? I'm not sure. So I'm going to put it like that and hope I get it right. Hopefully I won't damage if I get it wrong. It shouldn't be too hard. If I get it wrong, I just pull it out and flip it around. There we go. We have a chip. Beautiful. One chip. Okay. What should I do next? I kind of want to do the wire. I'm looking for a little green wire. I'm going to take some of these wires out and just put them down here. There's a lot of green wires. I have no idea what size I'll need, but I don't think it's that big. I want a smaller green wire than these. These look... Please tell me they've got one that I want. Ooh, what's that one? Is that shorter than the others, or is that the same length? These are all the same length! There's no little green one. I have to make it myself. Okay. If that's the case, then it seems that this wire goes in. Alright, get in. There. And then, if I... pull it out again. The right spot. Okay. And then I grab it with the tweezers and bend it. Yeah. And see if that still fits, because I'm not sure if it will. I gotta get this as beautiful as possible. Ooh, that looks good. I like that. Is that green or blue? Oh wait, it could be blue. It has a different color wire to me. But do I see any blue wires that would actually fit in that spot? No. You know what? We'll use green. Screw it. I'll just use what the fuck I want. It doesn't matter. Possibly. Give me a sec. I just need to be able to manipulate this a bit better. I'm going to... Oh god. Okay, so that goes there. And and about there. Keep it that way a little bit and go bang. And now, this is fiddly. Get back in there. Oh, beautiful. Alright. Now I just need 1, 2, 3. So it goes there. Now, supposedly I should cut it around there. Okay. So it goes there. They say you should count 1, 2, 3. And then cut it right there. So you get a little longer. Oh, hold on. I need to pull it out. Okay. Give me a sec. I'm just going to again measure it about there. Hold on, we'll use that one. Got it. Okay. Then all I should need to do is turn it down. There. We should have a perfect one. This should be perfect. If I'm right, it should be perfect. Nope. Get in the right hole. There. Where we want it. Ah, beautiful. Look at that. Oh, that is sexy. Hell yeah. We have an wire. I'm not sure if it was supposed to be green, but it is now. In the end, it don't matter. It's one wire. What are they going to do about it? I'm glad I got this thing though. This is cool. Alright. By the way, this thing is awesome. This little container they gave me. Alright. Nice. Now I have a beautiful little thing. Alright. Shall we do... You know what? Let's do the little ones first. These should be easy. So I need a little black one and a little white one. There's some very little... I need like... Freaking... Even my tiny hands don't fit... won't grab these things. Look how small this is! It's tiny! It won't even focus! I mean, it won't even focus anyway.
So ever since I uploaded a few videos of...
what are you doing? Why are you there? Get back.
There are a lot of ways to
Get
build
back.
a clock circuit.
Go
for a
back.
computer.
Oh, fuck. Whew. Okay. We're good. Okay. Is that even going to be long enough? Hold on. Look, this pin here. And... Whoa! It sprung out like a little frog. Hold on. Try again. Negative. There we go. Beautiful. Let's see if we can't find a positive that'll also fit. Why do they cut negatives that small but not positives? Whoever cut these must have given up halfway through. Ben, was that you? Damn it. Not happy, Jen. Not happy. Look, it won't fit. I can't get it in. It's too long. Alright, let's grab one of the big red ones then. I'd rather cut one of those down than one of the small ones because I'm less likely to need big ones. Okay, so it goes in there. We want it there. Right? If I grab... No, we want it there. We want it tiny, okay. This is like that. And then we want it... Oh, I can do with this. There's a cutter. Just cut it down to the size of the other one. Hold on. Bang. And, oh god, this is gonna be tight. Oh god. Hold on, I need to unbend it. That'll help. Yeah, got it. It might be a little short. A little more. Yeah, that's as good as that's gonna get. Oh crap. That's gonna get. It's trying to strip itself now. No, don't do that. Stupid wire. Now I gotta crimp it down and make it straight again. Come on. I'm sorry if you can't see some of this. This is really fiddly. Alright, my running commentary hopefully will be good enough. Okay, I think this is good enough. It's not, doesn't look good, but... Who am I kidding? That's terrible. That's the worst one yet. But hey, it's in. We have a positive. There. Done. Okay. And with this one that I've already cut, I might as well... look at doing this. You would go there. Right. And then I will go like this. About there. Twist it, right angle. Get it a bit further and go whoop, right angle. Beautiful. If I put you there, straighten it. Ooh, this one's going to be epic. Along there. Quickly. Pull that out. Twist it until I get the right angle. Turn it. Oh yeah. Oh yeah. And then grab it. Just add a little kink to it so I know where to cut it. Measure it. And cut it 3 holes beyond. About there. There we go. Now we have that. Now we have our bridge wire. Donk and donk. Okay, it's a bit long, but who cares? Look at that. Beautiful. Now the positive is connected to the positive. Awesome. I love it. Excellent. Woo! Okay. And we need a negative wire, which I have to make as well. Wait, I don't have a long enough negative wire. I legitimately do not have a long enough negative wire. What the hell? There's a screw there from something I was undoing. I was unbuilding before. Getting distracted. Don't worry about this. I've got a plan. Oh. Which one was this that had that? Not the clock module. I think it was in the 6502 computer module. It had a bunch of rolls of wire. Maybe I'll be able to get some out of here. Black wire. Found some. Found it. We're running on this now. Haha! Oh crap, it's twisted! Who twisted this? This is solid core. Straighten, 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 straighten. Finger straighten, fingernail straighten, fingernail straighten. Yeah, it's gonna be better. Okay. About there. I'm going to strip. Oh, I cut. I didn't strip apparently. Well, I stripped some of it. There's a little bit more. Wow, that's really bad. Okay. I might have done that too long. Well, I can right angle that now. Bang. Okay, this wire is a little thinner, unfortunately. But it'll work. For my purposes, it's work. It's still solid core wire. Eh. Wait a minute. Wait a minute. Out there. Eh. Dunk and dunk. Nice. Wish. This is not straight wire compared to the other stuff, but I do not care. And dunk. Oh, I'm slipping off the camera. Sorry about that. This is very slippery. I should have stuck it to the board first. Up. Okay. There we go. There we go. I'm just gonna guess. This one should be roughly the same. We'll do it there. And then we'll grab this. Roughly the same length. There. Ah! Crap, I lost it. No, I didn't. It's on my leg. Win. Then eater. It is. Look how small these wires are. These wires are tiny, and I'm not in the frame. There we go. Oh, it focused. Thanks, C5. Thanks. This camera is so old. It's like a C920. Not even a C922. It's just a regular old C920. But yeah. Come on. Getting caught on the other end. Trying to strip this wire when I've already bent it is a bit wrong. There we go. That is stripped. We stripping, boys. Oh, that's a bit wrong. Okay, that's not perfect, but it will do. It's way nicer than it has any business being, so I'm okay with it. Just get those off the edge. You may be realizing that I'm actually using core flute as a working surface. It does make it nice and slippery. I should probably take the backing off this and just stick it down, but I'm not going to for reasons. This is more to help me prevent me from losing things in a lot of ways. Although I might stick it down right at the end. I don't know. But hey, hopefully I don't have this chip the wrong way around. If this chip is the wrong way around, I'm going to have to pick it up and turn it all the way around. I'm not sure because if you look at the video, I'm not sure if you'll be able to see this, but hold on. Oh, that's the wrong one. That's the face cam. That one. If you look at the video, you can see
computer. But, we want something that's relatively flexible. We can adjust the speed. We don't want it to run too fast. We want to be able to see what's going on. And so I'm going to use the 5.5 with this is just 5 integrated circuit.
There it is. You see that little dot there? On that? I don't really have anything like that. Like, the most I have is... I'm not sure if you'll be able to see this. Well, that's like a little notch. Not sure if you can see that. It's not really working. This torch is way too bright. But yeah, there's a little notch on the top there, right in the middle. So I just have to hope that that's how that's meant to go. But yeah, that notch is notchy. It's really annoying. But hey, we've got the negative and positives done. There, and those. I can actually and I have my power wire here. Is this beautiful thing with this end? That's the power wire. I just have to plug it in. Yeah. Okay. So continuing on, what's next? Okay, so we have a resistor going from this pin to this pin, basically. No, this pin here to the which pin? Oh, hang on, that's wrong. That's meant to be up here. Hey, what? Oh, there. Fixed. There, that's where that's meant to be. I was looking at it wrong. If this chip is around the right way, that's where that should be. Yeah. Make sure that's in properly because it's a bit dodgy. Yeah, making wires like that is really hard. That one was pre-made. That one I had to do myself. Pre-made so much nicer. Anyway. That's just a... Okay. So now we have that. I need the resistors. And specifically, I need a red... Well, a yellow... black and red. I'm pretty sure that is. I got these resistors here. I am not sure if these are the right ones. I'm not sure if these are the same ones he's using. He's got 3 different ones. I've only got 2. What the hell am I supposed to do? Oh wait, no, there is 3 different ones. Hold on. I think. Yeah, no. Oh. Yeah, no, there is. So, we have this one, which I don't know if you'll be able to see it, because there we go. You can see the colors of coding on that. Actually, I think I actually meant to go this way. That is, I believe it's brown, black, and red. Brown, black, red. And that is brown, black, red. That is from 5 volts to the second pin down. No, yeah, to the second pin down. And then there's this one here, which is... What even is this? Red, red, brown? I think that's this side here. On the LED to the negative. This one? What is this one? Is this one right? Okay, this one makes no sense. This one is actually brown, black, green. I'm gonna have to do some comparisons to figure out exactly what the differences between these two are. Because I'm fairly sure that, yeah, brown, black, red, the gold stripe. Brown, black, green with a gold stripe. We've all got gold stripes, so that's fine. And red, red, brown. I'm seeing red, red, brown's easy. We've got one. We've got that one. That one's good. That's on the left side. That's for the thing. But these other 2, brown, black, green. We have a brown, black, yellow. Could be that. I don't know. And hold on. Brown, black, red. All right, that's this one. We've got one that's slightly off. Do you know what? I'm pretty sure that if that's the case, it's probably a substitute item. It's probably tolerances slightly different. Hold on. Let's see if we can't find a resistor calculator online to work out the ohmage of these resistors. I don't have a reference sheet on hand and I can't bother working out. Resistor calculator. Here we go. Okay, let's see what we got here. Ooh, fun. Okay, so the one that I have is... Need the light again. Brown, black, green. So it's brown, black, green with a gold. Calculate. It is 1 mega ohm. Plus or minus 5%. That's fine. That makes sense. Okay. He, instead of the green, has a yellow. What's the difference between... Or is that a yellow or is that a... Oh, no, it's yellow. So if I replace the green with the yellow, what does the yellow do? 100 kilo ohm? Okay, that's way off if that's the case. What about the orange? It could be orange. That's 10 kilo though. Yeah, no, it's definitely a 4-band resistor because it's got the tolerance color and the multiplier color. What the fuck have they given me? They've given me 1 mega ohm. Okay. They've given me this one, which is red, brown? Yeah, red, brown with a gold, which is also 220 ohm. Okay. And they've also given me a brown, black, red. Brown, black, red. And that is 1 kilo ohm. So I got 1 mega ohm, 1 kilo ohm, and 220. 1 mega ohm, 1 kilo ohm, and 220. He's using 1 mega ohm, 1 kilo ohm. No, he's using 1 mega ohm. Wait. That's 1 kilo ohm. So, yeah, 1 kilo ohm, 1 mega ohm. No, 1 kilo ohm, 220 ohm. That's for the resistor to keep that's for the diode to keep the diode safe, though. That's not actually in part of it. And then this one is 10 kilo ohm or 100 kilo ohm instead of 1 mega ohm. I mean, it's the only one I've got, so I'm going to use it. It probably won't matter too much. It'll just change the timing slightly. But maybe it's got something to do with the variable resistor I have. Where did that go? In here. In this bag. If I go back to this, and you see, I've got this little thing here, which I believe this is a different potentiometer to what he has. So, yeah, there's a neat little button there as well. Look. Beep, beep. But yeah, because of that, I'm going to substitute the one with the green line with the one with the yellow line with a green line. I think that's the only thing I can do. So with that, let's just don't bend just yet. Oh my god, these pins. Okay, so we are going here, right? So if we just we're going there. This is way too high, by the way. But that's all right. And then in that one there. Okay, cool. Now all I have to do is go there and cut the legs. Ha ha ha! Legs! Off with your legs! This isn't working as well as I thought it would. Apparently my measurements were shitty. Because I am way not going to be able to reach that. Let's just straighten them out again. There. Yeah, I know I shouldn't do this, but end it straight right at the end. Instead. And Badoosh. Sploosh, sploosh, badoosh. And. Okay. I don't think these things have a polarity, so I think they can go in any which way you want. As long as they go in. Oh my god, that is difficult. Why do you have to make things so difficult? Okay. Oh, it's in the wrong one. Nope, we want it to move over one hole. We want it in. There. We have one in. Look at that. Woohoo! Hell yeah. That's the one that's mismatched, but who cares? It'll work. Hopefully. Now we need brown, black, red. I think it's this one. Okay. Time is it last? It's not been nearly an hour already. Okay, judging by the hole spacing, and if you look at this, I'm gonna need all the freaking bend I can get, so I'm gonna bend it right at the edge. I don't like bending it like this because it's like too close, but Bend. Bend, bend, bend. Okay. Yeah. There. Ow, these freaking wire cutters work so freaking well. I'm so glad I bought these. They were not cheap, but I bought them and they were amazing. They're amazing. And then that to 5 volts. Come on, get in the 5 volts. Press in. There. Done. Now I have that. It won't focus again. But there. That's what I have. Okay. Now. Okay, so just below the 10 line is where they put that. They also have a
555 timer, and that's
down
classic.
again.
I want to be able to see what's going on.
Like, yeah, here we go. Now I can actually see where they go. Except for that, but I think I can see what's going on there. Okay. So. Let's go for the capacitor next. This does have a polarity though. I'm not sure which way. Because these are different capacitors. These are blue. Oh, hang on. So, one leg is longer than the other, and there's also a marking on the side there. Looking at what he's got, his marking is this way. So, shorter leg to the right. Okay. Let's just bend them outwards. Like that. Like that. Do the splits for me, you little capacitor. And we're going straight into the green wire. Second pin. Okay. That would be, we were there, so we want to cut it sort of there, I think. We want to cut it sort of on that. Out there. I'm just sort of hoping I did that right. Okay. So that goes there. And we just go whoop, bend it along there, button it, make sure it's 90 degrees. Put it in, see if we get it right. Okay. This one's going to be really hard to do though. Need like a tip. Just the tip. We do that. That should work. And cut this end. Oh, if I break this, luckily I have spares. Hopefully it won't show up and break everything else though. There. Uno capacitore. I hope that's the right way around. If not, well, I have a mountain of them, so hopefully there's some spares in there. Nice. All right. Now, sorry if you can't hear me very well, by the way. Why did I get different parts? Because the nature of electronics is everything works within a tolerance for a start. And also, this is a timing module, right? I know for a fact that the timing is based off of this capacitor and these two resistors. So the resistances and also, well, no, yeah, that's what the timing is. And also maybe the resistor that goes into the LED, but never mind that. Actually, no, that's the output. So that LED there gets the output. So with that being said, you change the difference between these two resistors and the wave will change. So you need to work out a certain set of resistances to work out how to get a perfectly square wave. That's what I think that's what he was aiming for. So you want an even time on and an even time off. So maybe this is my guess at what's happened here, because he probably couldn't find the same potentiometer, or maybe thought this potentiometer was better. Or maybe, actually, I'm not even using potentiometer for this one. That's for a different timing circuit. There's like 3 timing circuits in there. So maybe he couldn't find the right resistor, or realized this would be a better resistor for this capacitor. So the values have to match up. I don't know if he has a different value in this capacitor or not, because I can't see the side of his. This capacitor is rated at, I'm not sure, let me get my torch.
And so I'm going to use the 555 time.
Shut up. It's rated at 1 nanofarad. Which, you know, he could have a 10 nanofarad one there, or a picofarad, or something like that, which means you would require different resistor values to get it right. So my guess is because he's got a different capacitor, because it's not always easy to get the exact same capacitors, he supplied a different resistor to get the timing right again. Possibly. The other option is because this is a sort of a crude timing circuit anyway. It's a 555 timer with you know, the timing values, whatever. This will still do some on-offs, right? It won't change all that much in the grand scheme of things as a result. So when I get this, which is what we're going to do next, we want the yellow one, a yellow LED. Oh man, this is going to be annoying. I forgot what polarity these things have to be. Which one goes to the positive and which one goes to the negative? LED polarity. Simple ways to determine LED polarity. All right, longer lead is supposed to be positive. And this doesn't appear to have a flat, so yeah. Longer lead is positive, which means the short lead should be negative. And because looking at the 555 timer, the A-stable one. Oh, fuck. Jeez, that was loud.
My fucking back.
Oh, please don't ask me to do push-ups though, because my camera is in completely the wrong location. I don't want to have to set it up. You fucking bastard. I might just reject the push-ups. I'm sorry. But I will do the other ones. Apologies, but I have refunded those points. I should have disabled push-ups because, like I said, my push-up camera is also my desk camera, and it's too much of a pain in the neck to move it around all the time and reposition it. It's already moving a little bit anyway. This is probably meant to be about there. But whatever. I think it's because of that. So apologies, Jay. Apologies. No push-ups, just stretch and hydrate. I'm ignoring the push-ups ones and probably just refunding all of them. For the duration of this stream, and many other ones like it. Not that I shouldn't do push-ups. It's just that I'd want to get another camera and I don't have one. So yeah. Okay. So. What did I say? Longer lead was negative? Longer lead is positive. If that's the case, because we're going to a negative, that means shorter lead will be on this side. It'll be like that. And technically that would work, but no. So, yeah. Let's hope that these are correct. In there, there. And you around like that, and you around like that. Okay. Well, that's sort of there. On that one. Okay, I see where to do it. I see where we want them. Like right there for this side. Like that. I mean, it's not a big deal because these are diodes. This is a diode, so... So that would go like that. And then... Oh, crap. Yeah, let me just trim this down a bit. So I can actually see where it's going to go. It's just below the 10, I think it was. No, it was level of the 10. I think I was going to go there, wasn't I? Hold on, so this was 1, 2, yeah, so it's on this row here. On the second point. That's where it will be. And it's level with not the green one, but the one before the green one. Okay, I see exactly where I need it. Also do that side like that. So that is second one down? Second one down. So it would be there and there. Alright, now I just need to trim it. This is where my perfectionist mentality boots into high gear. Oh crap, which way was that? I'm gonna guess and say it was that way. If the LED doesn't light up, you flip it around. There, it's in. If it's wrong, we will know. We're nearly ready to connect this thing up anyway. Connect this thing up to power. By the way, I should plug my power cable into the USB port so that I have it ready to go. I'm not going to plug it in just yet, but it's going to be right there. And reach over, check it into the hub. There we go. We have 5 volts. Naked 5 volts. Right here. Beautiful. Luckily, it's only 5 volts. Alright. We need one more thing, and that is the red-brown resistor. The only one I haven't used yet. Okay. And we pretty much need to do the same thing as last time, so. That. Dab. So if I'm gonna do this with the resistors on my thing, because I'm usually need them as short as possible. It's really difficult. That. Luckily I don't need to wire strip these things, because they don't have strippable wires. Hop. Straighten and pop. Alright, now let's see if we've gotten this correct. Give me a sec, actually. Get it in there. There! Everything's connected. Look at that. Moment of truth. Moment of truth. Have we built this 555 timer correctly to the point where it blinks? No. Well, that lit up. But is it the wrong way around? Just to be sure, I'm going to make sure. I'm going to double check because it could be sending power down the wrong way. No. Okay, that was probably correct. Okay then, what about this? Is that the wrong way around? I don't like this, it's not blinking at all. It seems dimmer though. Try flipping that around again. No, it's not that. I mean, we have an LED that lights. But that is not right. Right back where it was. Why is that brighter when I do that? I need to look up this chip to make sure I've got it correct. Hopefully it's not got a different data sheet. Where's my torch? What did I do with the torch? What the fuck did I do with the torch? What the fuck did I do with the torch? I dropped it on the floor. Okay, let me look this up online. So I'm seeing NE555P. Alright, hold on. Alright, it's gone straight for the Texas Instruments. I want the data sheet, please. Give me the data sheet. Okay. We'll go for this side. Texas Instruments, you know, the guys who make the calculator also make this chip. Okay, yeah, no, I had it the correct way with the notch up the top there. So this is in its correct spot. I'm willing to believe it's the resistor. I'm willing to believe that the only thing that makes sense is that it's the resistor. Because we know that the resistor is... What was it again? Brown, black, green. Brown, black, green. Right? Which is 1 megohm. Whereas I'm pretty sure he had a brown, black, yellow. Is 100 kilo. And the other one is brown, black, red. Which is... No, wait, no, that was wrong. That was meant to be gold. I was meant to say gold. Brown, black, red. Which is 1 kilo. 10 kilo. 1 megohm. I kind of want to read.
Timer. This is a classic integrated circuit here, the 555 timer, and that's what this chip is here. And so you can tell pin 1 here is by the divot, and 1, 2, 3, 4, 5, 6, 7, 8. And right now I'm powering this with, this is just 5 volts coming in from a cell phone charger that I've cut into the USB cable and pulled the 5 volts out. And to power the chip, power comes in 5 volts here on pin 8 and ground to pin 1. You can actually go up to, I think, 17 volts or 16 volts or something with this chip, but 5 volts works. And to control the timing, you've got 2 resistors and a capacitor. And so the first resistor here is going from 5 volts to pin 7. This is a 1K ohm resistor. And then from pin 7 to pin 6, I've got a 100K ohm resistor.
Yeah,
and
I got
then
a 1
pin
meg.
6 is connected around to pin 2. And then from pin 2 to ground, I've got this capacitor, and this is
maybe I'll try the
220
220K, even though that's meant for LEDs.
You can see the positive side is connected here to pin 2. So
the other option I could do is check to see whether I've got anything else in my other hits.
And so those resistors and the capacitor control the timing.
I do have a bunch of other kits behind me that have a bunch of
is
things.
On pin 3, and so that's just connected to this LED. And you know the output can drive a fair amount of current. So
because 100K versus 1 megohm is a lot of difference.
220 ohm resistor here.
But this is probably flashing.
So
it's just flashing so fast I can't hear it.
How does it work? Well, a good place to start, of course, is the data sheet. This is the data sheet for the 555 timer. And you can see they actually give you a whole schematic of what's going on inside that chip, which we won't go through all that. But they also give you a bunch of other stuff in here. One is this sort of block diagram that gives you a little higher level view of what's going on. And so you can see there's a couple comparators. There's these 3 resistors. There's a flip-flop that these comparators connect into, and then there's this output stage. So this is pretty interesting. I don't personally like the way that this is drawn. It's kind of drawn to line up with, it doesn't show like, okay, there's 3 things, diagrams. So I drew up my own that I think explains this a little bit better.
This is it. And so you can see threshold and trigger, and these 2 resistors here are the same as those 2 resistors there. And so the differential between them calculates
timing. You can see, just like those other diagrams, there's the 2 comparators. There's a flip-flop. It's actually an SR latch. I think it's probably a better look at what we've got. So this is a 1K resistor.
That's right. You can look up this stuff.
Going from 5 volts to pin 7.
Yep. So I've got that.
And then between pin 7 and 6, that's this 100K resistor.
Yep.
Here. And then you can see pin 6 and 2 are connected. That's this little green wire going around here. And then between pin 2 and ground, we have this 1 microfarad capacitor. And then over here we just have our LED, and this is a
1
I think it's a 220 ohm
Let me just check
resistor over here. So this is our circuit. And to understand how it works, we can kind of look at what's going on inside the 555 timer. So just start by looking at this path through here. You can see we've got our plus 5 volts up here, and then of course our ground down here is 0 volts. And then there's these 3 resistors, and I think each of these resistors inside here is 5K. So 5K, 5K, 5K. I think it's a complete coincidence that it's a 555 timer, but anyway. But what these do is these set up a voltage divider. And so at this point here, you've got 1/3 of the voltage between 0 and 5 volts. So that's 1 2/3 volts. So 1.67 volts we'll call it. And then at this point here, we've got 2/3 of our 5 volt supply. So this is 2/3 is.
I think mine is just going too fast.
And so you got this voltage divider. So 5 volts, you go through this resistor, you're down to 3.3. You go to this other resistor, you're down to 1.6667, whatever. You go through this other resistor, and you're down here at ground at 0. And what that does is that sets up these inputs for these comparators. And the way the comparators work is there's a positive input and a negative input. And if the positive input is above the negative input, then the comparator switches on, and the output is 5 volts. And if the positive input is below the negative input, then the comparator switches off, and the output here is 0 volts. So let's think about what happens when we turn this thing on. Get this out of the way here for a second. So what happens is, let's assume that these inputs over here, this is all 0 volts. So we've just turned this on, the stuff is 0 volts. So we've got 0 volts coming in here, that is below 1.6 volts. And so this comparator turns on. And so that triggers the set pin of our SR latch. And if you don't know what an SR latch is, I've got a video on that. But basically it's got a set and a reset. And when the set goes high, then the output comes on. And when the reset goes high, then the output turns off. And then of course, if they go low, then it remembers its last state. And there's both the output here, and then there's the 6. The capacitor is going to start to charge. And so if you look at the charge on the capacitor, which is also the voltage here going into pin 2, it's going to start, move this, so you can see here.
Yeah, so you can see.
It's going to, and it's going to keep climbing and climbing and climbing as this capacitor charges. And so what's happening is the voltage here is increasing. And at some point it's going to increase above 1.6 volts. And if it's above 1.6 volts, this comparator will turn off because 1.6 is no longer above whatever this voltage is. So this comparator turns off, and that's fine, right? Because the latch is going to latch its output. So we're not asserting the set pin anymore, this set signal. But if we haven't reset it yet, we're still going to have a high output here. But eventually, this voltage is going to reach 3.3 volts, and it's going to maybe go a little bit above 3.3 volts. And at that point, that voltage is going to be above 3.3 volts, and this comparator will turn on because the positive input here is above the 3.3 volt negative input. And so this will turn on, and this will reset the latch. And I guess I didn't give myself enough room here, so ignore that. So this is our output. Our output is going to get reset when this hits 3.3 volts. So, so if this is like 3.3 volts on our capacitor here. Maybe this down here is 1.6 volts, and then we'll say this is 0. So we started at 0, we went through 1.6 volts, nothing happened, and we turned off the set pin, but we stayed latched. And then we get up to 3.3 volts, and at that point our output turns off.
I think it's just flashing extremely
is our not output, our inverted output, this turns on.
Sometimes I see it flicker.
And that's going to cause current to flow from here through into the base of this transistor, and that'll turn on this discharge transistor. And so then what happens is, current can now flow through the 1K resistor through this discharge to ground. So okay, that's not very exciting. But what's more interesting is that current can also flow from the capacitor through the 100K resistor. So before we were charging the capacitor in this direction. Now we're discharging the capacitor. Current is flowing from the capacitor through the 100K resistor and through this discharge. And so the capacitor is going to start to discharge. And it will discharge for a little while. And of course, it'll, as soon as it starts discharging, it'll drop below that 3.3 volts. And so the reset will turn off. But again, this is latched, so nothing happens. But eventually, the capacitor's voltage will drop below 1.67 volts. And now, with this below 1.67, the set comparator turns on, and it sets the latch.
I've watched
again.
all this before.
And so when we set the latch,
paying too much attention.
When this gets down to 1.6 volts, we set the latch, we turn the output on. We also turn the discharge transistor off. So we turn this off, and so we're no longer pushing current through the base of this transistor, and so this transistor is off. And so no longer is the capacitor discharging. We're back into this state where the capacitor is charging again. The capacitor will charge, our output is on, eventually the capacitor will get back up to 3.3 volts, this will switch. We'll start discharging again, and this will turn off. Capacitor will discharge.
I got a bunch of random resistors in here,
it's off.
Somewhere.
Capacitor will charge, discharge, and so we get the capacitor is charging and discharging kind of like this, but our output here is this nice clean square wave. And that's what we see when we look at the circuit here. We see our LED flashing. And of course we can control the rate that the LED is flashing based on the values of these resistors and the capacitor, right? Because you know the rate is set by how quickly this capacitor charges and how quickly it discharges. And so how quickly
brown,
it
black, orange
is going to be dependent on these two resistors and the capacitor. So the bigger these resistors are, the slower it's going to charge. And of course, the bigger the capacitor is, the longer it's going to take to charge. And then if these resistors are smaller, then it'll charge faster. If the capacitor is smaller, it will charge faster. And then for discharging, so the time when this is low, it's just discharging through the one resistor here. And so, again, if this is a bigger resistor, it'll take longer to discharge, and so this will be low
I'm just doing this without
for longer.
changing anything else.
If it's a smaller resistor, it'll be faster.
This is brown, black,
so
orange.
It's
not brown, black, yellow, but hopefully it'll do.
The rate here. And so one thing you might notice is that, I chose a 100K resistor here, and then a relatively smaller 1K resistor here. I mean, this is only 1% of this. And that's because we're charging through both, and when we're discharging, we're only discharging through this one. But I wanted this square wave to be fairly symmetrical. And so by this only being like a 1% difference in the charging from discharging, you end up with essentially the same time that it's off that it's on. It's sort of what's called the duty cycle. And if you look at the data sheet, they actually give you some formulas here for figuring out the time that it takes to charge or discharge. So charge time, discharge time, and they actually show a nice little graph that looks very similar.
Why is that one blinking when mine's not?
But you can see
everything is exactly the same.
They give you the charge time is based on RA plus RB. I think they're calling this RA and this is RB, times the capacitance, which is the C here. Whereas the discharge time is just based on RB, right? Because we're only discharging through that one resistor, so you don't see RA in there. And then the total period is RA plus 2RB, right? Because it's RA plus you're going through RB twice for the total period times our capacitance. And so we can figure out our total period just using this formula. We can pull out a calculator here.
Yeah, I could work this out, but I really don't want to. My brain's just not functioning for this. I'm trying to tell if it is flickering even with this. It seems to change brightness when I put the resistor in, but it doesn't actually seem to do anything else. Like double the resistor up to make the resistance go weird. If you double resistors up, the resistance will essentially be that of the same value. It seems like this chip's not doing anything that it should be doing. But I'm looking at what he's got, and he's got the exact same thing I've got. I don't really want to burn out my LED. Unless it's that. I have that plugged in wrong. Alright, let me get the pin out of this chip. Maybe these chips are slightly different. I mean, they're 555P and he's got the 555. I don't even know what it is. Let me see. Where's his data sheet?
Same thing. But I don't really like this. Well, a good place to start.
LM5555. And I have the XX555. What is this? It's the NE555. It's slightly different. So let's see what the pinout is. Ground trig, discharge out, threshold, reset, cont. What does he have? Do we have a slightly different pinout? I would not be surprised if we did. This is troubleshooting.
A bunch of other stuff in here.
A ground trigger output reset. Ground trigger output reset. VCC, discharge, hold, and control voltage. VCC, discharge, threshold. Threshold, yeah, no, it's all in the same spots. It's all in the same spots. Ah, you son of a bitch. I want this to work.
Well, I figured out the mystery. So we calculated 139 milliseconds and we were seeing about double that. And the problem turned out to be these capacitors. So, you know, looking at
so this is why he's not using the same. I'm not using the same capacitors.
50V. So I would assume that that means it's a 1 microfarad capacitor, 50 volts. It's got this 1022. I assume that that's a date code of some sort. Maybe it's manufactured in 2010, the 22nd week of that. And that's all it says on it. So I would assume this is a 1 microfarad capacitor. Turns out, when I hook it up to my meter, it measures at 2 microfarads. So I don't know what's going on with that. I got a whole bucket of these things, and they all say 1 MFD on them. And they all, or at least all the ones I measured, measure 2 microfarads.
I don't know where I put it.
So instead of 1 microfarad, it's 2 microfarads. And so, you know, if we plug that into our formula, we had 1 microfarad there. Instead of we plug 2, we're basically multiplying by 2. So multiply that by 2, 278 milliseconds. And, you know, we're measuring 263 milliseconds period here, and that's
I wish I had a freaking
that's much more in line. That's certainly within, you know, we've got 5% tolerances on these resistors and stuff. So 263, 278, close enough. So very interesting. I always assumed these were 1 microfarad, but apparently not. If anyone knows why they're marked that way, maybe I'm missing something obvious, but I would assume that 1 MFD means 1 microfarad, but apparently 1 MFD means 2 microfarads. Go figure. Yeah, so 263 milliseconds, that's much more what we'd expect. And so if we take 1 over 263 milliseconds, we get about 3.8. And so that tells us this should be flashing about 3.8 times per second, and that, I don't know, visually seems about right. So I think we're almost done with this circuit. It looks like it's working. I did want to talk just briefly. There are some power supply recommendations in the data sheet.
Where to get a power supply.
And I wanted to talk a little bit about the power supply. We've got, this is just a cell phone charger. This is from Apple, which is actually a very good power supply if you get a genuine Apple one. But in any event, you know, it looks like everything's working fine. You know, our LED is flashing. We've got our nice light up screen, clock output here.
I can't really show
so
this.
You could probably use this and it would work okay, probably. But there are a few things that the datasheet recommends doing to reduce noise. And so one thing it recommends doing is putting a capacitor on pin 5. We're not using pin 5, it's control voltage, it's for some other features of the 555 timer that we're not using. And it recommends putting a 0.01 microfarad capacitor.
Yeah, I've got some of those. I will probably have to use them later. Let's see. Let me check these. I'm just going to check whether the ohm ratings of this are exactly what I was seeing. Yeah, that's 1 mega ohm. Wait, that's 1 mega ohm? No, that's not 1 mega ohm. It's like Or maybe it is. 0.98. These things had a backlight. Just bring it closer. Yeah, M. Mega ohm. 0.987. And this one is 1. What? What? 1? What? Oh, 0.98. Oh no, that's kilo ohm. So that's 1 kilo ohm. And that's 1 mega ohm. Okay, and this one is... Yeah, 220 ohms. Give or take. I want to replace the 1 mega ohm with 100 kilo ohm. That's what I need. What was this one that I had before? Was that... Wait, where is the one that I had before? There it is. Dodgy looking. This was... $10 kilo ohm. I need 100 kilo ohm. At least I want 100 kilo ohm. That's what I have here. Butt ton and 1 mega ohm. I have an absolute butt ton of them. They're identical. God, I got some really odd ones. I got some all orange. Orange. Gold. That was the closest thing I had, and that was 10. Not exactly what we want. I don't have anything with a yellow on it, do I? No. You have some odd ass. This one. What is this one? What is this odd looking one? I'm just gonna measure these things. See if I can't find something that is close to one X number of kilo ohms. That is 1 kilo ohm. Like 1.5 kilo ohm, which is similar to these green ones. No, that's mega ohm. Yeah, that's 1 kilo ohm. That's 1.5 kilo ohm. That's a little better, but it is no odd one out. Where's the one I had? Where's the one I measured before go? The odd one that I had. One with the orange. Wait, is that the orange? No, that's brown, green, orange. Oh, I might have put it back. This sucks. This sucks donkey nuts. Would mind to just pick something out and try it. What's this one? This one's an odd one as well. What is this one? It's all like reds and oranges. I am seeing 2 kilo ohm. 2 kilo ohm. That's a little better. It's not... At least it's not 1 mega ohm. is... Yeah, I got 1 kiloohm. We try to put a 2 kiloohm on there. Let's try 2 kiloohm. Sort of thing. Pull that one out. I just want to be able to see it blinking so I know I've got it right. So if I can see it blinking even intermittently and weirdly, I'll be happy. So let's just jam that in there like that. It's not blinking. Alright, let's try the other chip. I have a busted chip. That means I can't finish it. No, this one's the same. Damn it. This is annoying me. I don't know what's wrong. Even with a 2 kiloohm chip, I'm still not getting anywhere. That really is that for it. Maybe that is busted. Maybe because it's nanofarad, is, you know, nanofarad. Let's try a different. Try a variable capacitor? Probably not. They're highly unlikely to have someone to have. I used to have one. I swear, if this fixes the problem. It's the capacitor that was busted. Look at that. Do you see that flash? Woohoo! Look at that flubber fly. Holy crap. Look at that. That is flickering like crazy. You can't really see it, but... Alright, where's my original one? Let's pull that out. Pull that one out. I'll have to rebend that. This is fucked. I had a busted ass freaking thing. Let's pull that out. Let's put the original back in. Right? Maybe it'll blink better. No, I fucked that up. Bring that back out. It was the capacitor. Was it? This isn't meant to go into the... Are these capacitors not have the right tolerance? Is that what's going on? Because I can't even see that anymore. It's not blinking at all. Whereas I had that one in. Like that. Is this busted now too? Am I just blowing caps? Is that what I'm doing? Am I busting caps? No. What's wrong with this one then? This one really is dud. That one's a dud. Okay, I have to bend a new one in. And yep, okay. I'm happy with that. I might actually bend that correctly and put that in. I don't know. It's only 1 mega and more, but which means it's very fast. But hey, who cares? I think I'll be careful when bending these. I think I'll bend it a little bit up from what it was. I think that might have been what I had. The problem I had. Try not to overdo it. tournament. And double check. Yep, still works. Yeah, let's straighten this one out and try this one. This is totally the wrong capacitor, but I don't have the right one. I'm going to trust that this resistor still works. So I'll keep using this resistor. But so I might use it for something else in the future, but like in terms of actually doing things, I'm gonna use this one. Better rep. My stash of random value resistors saves the day. Well, actually it didn't, it just helped. I still don't know what's wrong with the thing, but we do have a blinking light this time. I mean, it's blinking fast enough that the camera can't really see it, which is exactly what's happening. But yay. That's blinking. I mean, you can sort of see it because it's just blinking sort of in time with the camera. It's like brrrr, basically what it's doing. It's rolling its R's. Yeah. We have that timing circuit done. I don't know how fast it's going. Frankly, I don't care. Because I think it was 2 kilo ohm resistor worked. It might not work for the future, but it works for now. And with that, believe it or not, I am running out of time. So I think I'll start cleaning up. And we'll continue this some other time. Tomorrow, I probably will stream, but I probably won't be streaming this. So, with that being said... Let's stuff all our bits and bobs into my thing. Hi all! What's going on, bro? I'm about to finish up here. The nerdness is sort of over. Somewhat.
Okay.
But you can stay in here while I clean up. That's fine. I'm just gonna stuff all this stuff in here. Have you been watching, or are you just pop in to say hi?
I just saw you.
In the Discord
streaming, and I didn't see. I didn't notice that you were actually streaming tonight.
Yeah, I decided to because I got all my stuff for the kit to come in.
Oh, okay.
For my electronics kit
The
that I was planning on
breadboard.
doing.
Yeah.
Yeah, the breadboard stuff. So I've done step 1 of the computer clock, which is the stable 555 timer. Had a bit of a mishap with the resistor values. They gave me the wrong resistor values. And I also had a problem where one of my capacitors completely fucked up and decided it didn't want to work, which caused me no end to issues and caused me to do a lot of troubleshooting. But I figured it out in the end, and now it's flashing away probably a lot faster than it should be, but it's still flashing and you can tell. Because I found a...
how often do you stream, like, you building the breadboard stuff?
I'm planning to have it happen for a weeknight thing. So it won't happen during weekends and Friday nights. Just to, break things up a bit, just because I want something to do that's not like overly stressful and not like gonna fuck me up as much as gaming can. Just something to relax with. Stick a bit of lo-fi on, relax, try my darndest to build something, and come out at the end with something cool. Well, something that I think is cool. But yeah. That's the plan.
So what does the computer clock do anyway?
It's a clock. So it pulses. It turns on and off at a interval. It's the same thing that a regular computer clock does. It's just probably a fair bit slower than a regular computer we've got, you know, the computer we're building is a lot slower. I believe the intended speed for this kit is 1 megahertz.
Right.
And the only reason I know that is because in the C6502 computer module there is actually a crystal timer in there that is 1 megahertz. So I could use that as a clock instead, and that's exactly what the crystal timer in there is for. But the thing about this timer we're building is it's got a lot more interesting features that will help. Like, for instance, I can freeze the clock, which I wouldn't have been able to do with a crystal timer. And I can speed it up and slow it down, which, again, I wouldn't have been able to do with a crystal timer.
So would you be able to hook it up to your normal computer, I'm assuming?
No. This is...
Oh, okay.
No, this is for a computer I'm building. So I've got 3 kits here. I got this clock module, which is what I'm building now. Right?
Right. Yeah.
This one here, when I'm holding the breadboard for in my hand. I've got a 6502 computer kit, right? Which comes with a 6502 CPU. And that is 6502 is a legendary computer. Every modern computer has its roots in the 6502.
Right.
But it's a lot slower than it was, and than modern computers are. It's ancient technology at this point, but you can still buy you can still buy brand new CPU modules for it because it's used in like embedded development and stuff like that still, because it's cheap and easy to work with. But you can also use it for hobbyist stuff like this.
Right.
Yeah. But it is a legendary chip. So once we get this thing done, that 6502 computer module contains a small amount of RAM, a few megabytes if that. And it has obviously input-output pins that I can use to program stuff. So I have the third kit, which is in the bottom box there, on my screen, on my windowsill there, and that is the world's worst video card. It's not a graphics card because it does 0 graphics processing. All it does is it takes pixels from memory, converts it into something that a computer screen or an old TV screen really, but still, can understand. Mm-hmm. This video card supports, what did it say again? It said, 100 by 75 pixels. So a very small picture with 64 colors at 1 frame a second.
Basic. 1 frame, so it can do some level of animated stuff, but not and it will be laggy, I'm assuming.
Well, it's only because it's linked with the CPU, right? And the CPU is sharing the RAM, right? Essentially, the video output freezes the CPU. That's the limitation. They don't run in parallel, they run in tandem. Which means when the CPU is doing its processing, the video card is not outputting to the screen. When the CPU is not doing its processing, the video card is outputting a new frame to the screen.
Can't you just add? I don't know. This might be me being a little stupid, but can't you get some more like extra? I don't know, RAM. I guess
that is a possibility, because copying from RAM chip to RAM chip is probably a bit quicker than halting a computer so that we can share memory. That's essentially what's happening. There is a bit of a bus sort of situation going on as well. So, you've got to I can allow you to access it, and you to access it, and you to access it, and you to, yada, 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 yada. But yeah. And I can get a I think this video card has a memory chip on it. That is but it's a ROM chip, not a RAM chip. So I can program it with my little programmer here that I have. This one. And I can reprogram as many times as I need. But it's similar. You can really only write to it in a specialized way, and as a result, it's sort of similar to an older, just more likely burning a CD. Rewritable CD.
So, I mean, is this like running? What language do you have programmed?
It doesn't run a language. It runs. It's pure assembly.
Yeah.
Which is the lowest level language you can get. Basically, it's a series of instructions that you can give the CPU to do certain things. You know, load this into register A, load this into register B. It's so low level that it doesn't even look like a programming language.
Like, you haven't gotten to the software. You are just building it out.
I'm
right?
building the timing circuit right now. That's what I'm doing. So
is this like the first ever stream of the?
Yes.
What's it called? Like the.
This is because I literally received the timing stuff today, so I'm like, I'm gonna get started.
Oh, okay.
I can't guarantee this will happen every day of the week because there are other things I want to do. I've got some stuff I got to mess around with rust treatment and cleaning up stuff and installing a hard drive into my PlayStation 2. But it will happen whenever I feel like doing more on it and stuff. It's going to be a slow process.
True. Okay.
Yeah, I'm happy with what I've got now. So a few things I did off screen was build this power cable. All this is a USB cable, right? It's an old micro USB cable that I cut the end off of, right? And soldered a 2-pin header onto.
I can't see what you have created.
It's in my hand. You'll barely be able to see it. If I get my other camera, bring it back over. Right. So you see this? It might not focus very well, but you'll see it.
Hold on, like delay. Remember?
Yeah. I'm just trying to get to focus.
Yes, I can see that now. Yeah.
But yeah, you see that? So this just goes straight into the thing,
breadboard, and
bam. This is actually flashing. It's just flashing so fast that the camera can't see. But you can see that just plugs straight into it. Into the power rails. That's what these side pieces are. These side areas are the power rails on the breadboard. So the way a breadboard works, right, is the power rails are all connected. So you can
explain this to me because I have no idea how a breadboard usually works. I have seen them, but I have no idea how they work.
You see these black and red lines, right, on the end, on both ends, right? All the holes along this red line and all the holes along this black line are all connected via a metal carrier, right? So all the way along,
right?
If you plug something in here and send a signal, it'll go to here. So it's basically one long wire, right? When you turn it around and you look at the center piece of the board, it's different. Instead of going lengthways, it's this way instead, right? So there's a gap in the middle, right? And then you got two sections. And then two sections, there's 5 holes in each row, right? And each one of those 5 holes is joined together. So I can plug something in here and access it on the end. So that's why when you look at this, let me just turn that off, right? You can see how I've got it configured. So basically connecting a resistor on this hole connects it to this pin and this resistor on this end. Connecting this green wire to this one is basically making this row and this row identical. And blah 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 blah. So you do things by basically bridging certain connections. But the whole point of a breadboard is so that you can put chips along the center. This breadboard is perfectly wide enough to fit this chip without having to bend the pins or mess around. Right along the center break, so that you can access the pins and insert multiple things along each pin. And therefore you can configure the chip however you want to configure it. It's meant for prototyping, but in this case, this is a little project that you build it entirely on breadboards and it just works. And that's the entire design of it. But yeah, and then if I get myself another breadboard, let me find one. Here it is. So you can get different brands of breadboards, and some breadboards aren't as good as the others. And the easiest way to tell is by just feeling how something inserts into it. That clicks in on these breadboards. That clips in really nice and stays in there. It grips. It's got lips that grip. There you go. But this one, it still grips decent enough. Because I think I got this from another kit, to be honest. But it's not as sturdy feeling. It doesn't require anywhere near as much force to put it in or pull it out. But like, yeah, if I grab this breadboard, right? Another thing these breadboards have is actually tape on the bottom of them. This breadboard here is so old that it's actually basically non-stick at this point. But you can see that there's tabs along the center there, so that I can join these things together. It's a bit difficult because these breadboards are different brands and they might have different tolerances. But it does, if I work on it. Well, this top bit did, but none of the other holes are lining up, but you can join them together. The other thing you can also do is you can pull that apart and you can just have the power rails separately. And that way, if I take this one off, oh, I did that wrong. Hold on. Yeah, whatever. I don't care about this breadboard anyway, so there's my family knife. What I'm supposed to do is this. So if I do that, here we go. There we go. Oh, by the way, you look on the bottom, you can see the of this one because I've accidentally ripped the backing off. You can actually see the metal rails on the inside of it. There's the metal rails. But yeah, so now that I've got these two separated, I can actually just connect them together to create two long ways. Two sort of channels. Which is really good for doing stuff like buses and stuff like that. Like where you need like a row of connections all the way along. And you have modules that connect to the sides. So yeah, you can do stuff like that. I don't actually care about this breadboard now. I've semi-damaged it. I mean, it's usable still, but this bottom side's not really insulated anymore. Whoops. That's alright. I haven't used this breadboard in ages, and I can't remember what I was using it for. I was just messing around with it at the time. I've had this one for like more than 10 years. Might be why it's not as nice. But yeah, it's... rejoin it back on, and there we go. Back to how it was. You can do that with all breadboards. These breadboards are basically the same. You pull the sides off.
Right.
If you really want to, you can even cut down the middle. So you've just got the top side and the bottom side separately. Although that's how you're cutting through plastic at that point. But yeah. That's essentially it. How a breadboard functions. Any questions?
Not really, no. Like, I mean, it's interesting. I didn't know that you were streaming this today. So, like, if I knew, I would have.
No.
Hop on.
I started at the same time I usually would start, so 9 o'clock. So,
No,
you know.
Yeah, you know, I just
I don't
didn't check
announce
my.
that I'm about to stream beforehand with this sort of during the week. So, you know, if you notice at 9 o'clock, double check and see, and I might be on or might not be. You will
No,
take
it's just
half
that
an
I
hour.
didn't check. You know, and it's just that I didn't check my notifications and all that, so I didn't see the stream notification.
So, FYI, we had one casualty today, and that's this little blue capacitor.
Right. Looks like a what's it called? Like one of those things like a robot type.
No.
From...
Well, I bent the wires myself, but the problem with it is it appears to have gone, and I'm guessing this. I'll have to get the multimeter out and test it later. But I'm pretty sure it's dead because it wasn't functioning like it should, and I replaced it with another one. Now the circuit works. But what these things do is they hold a small charge. They're like really small batteries in some ways. Some people actually buy giant capacitors and run their cars on. Problem with capacitors is they lose charge over time. Like even when nothing's connected to them. So they make terrible long-term batteries. But because they can output their power, because they store, the amount of power they store is proportional to the amount of power that you put in. So if you put 12 volts in, it stores more power than if you put 5 volts in, for instance. I'm pretty sure that's how it works. It could be amps instead, but either way, that's how it works. That's how these things work. They are incredibly versatile, and every computer system uses them somewhere or other. Including modern ones. Including the ones that I'm using to stream this. Anyway. With that, I thank you. I hope to see you later.
This is a great info dump there.
Yep. I'm full of interesting knowledge. Sometimes good, sometimes bad, sometimes pointless, sometimes interesting. I've always been fascinated with electronics, anything tech really. So I'm right in my element here. If I didn't have to do physics in uni, I probably would have gone into engineering. But I didn't. Not my clothes. Get in the... Okay. With this... A lot of my spare stuff will end up in this plastic box I have here, full of random electronical crap. A lot of this electronical crap I've owned for all sorts of things. We have some very interesting stuff here, from cable headers to old breadboarding bits to little buttons to even USB headers. And these are female USB headers. So I can make something that you can plug a USB into. If I ever wanted to. I think I bought them to replace a USB header on something or other at one point. Can't quite remember. Yes. Anyway, alright. With that, I'll catch you later. Where's my button?
Yes.
Alright. See you guys.